Now let's move to the question number 4. The parametric equation of the curve are x is equal to x is equal to exponential of tangent of t and y is equal to 3 tangent square t. Find the equation of the tangent to the curve at the point e, 3. Give your answer in the form of y is equal to mx plus c, where m and c are exact. Okay, we need to find the equation of the tangent at the point e, 3. So we know that to find the equation of the tangent, we need slope. We will use slope point form, which is y minus y1 equals to mt tangent slope of the tangent time x minus x1. And the point we have already, which is x1 comma y1, which is equals to the e, 3. We need to find the mt, which is the slope of the tangent. So slope of tangent is equals to dy over dx at point 3 comma e, 3. So if we have the information of slope and we have the point, this we can find the equation of the tangent. So we need to find the dy over dx. We need dy over dx. So first we will use the chain rule, which says that dy over dx is equals to the dy over dt time dt over dx. So we will find dy over dt and dx over dt. So first we find dy over dt and dx over dt. So x is equals to e to the power of tangent of t. So dx over dt is equals to the derivative of exponential of tangent of t with respect to t, and derivative of exponential term remains same. So e to the power of tangent of t and derivative of the power, which is tangent of t with respect to dt. So dx over dt is equals to the e to the power of tangent of t, and derivative of tangent of t is secant square of t. So this is the dx over dt, equation 1. Now we will find dy over dt. To find dy over dt, we have y is equal to 3 times tangent square t. So dy over dt is equals to 3's multiple will remain same, and derivative of tangent square of t with respect to t. Further solving, we will have 3 and power will be switched 2 times tangent of t and derivative of tangent. And so dy over dt is equals to 6 times tangent of t and derivative of tangent t is secant square of t. So this one is dy over dt. Now from equation 1, we say that dt over dx is equals to 1 over exponential of tangent of t times secant square of t. So we will use this equation and equation 2 to find the dy over dx. We know that dy over dx is equals to dy over dt times dt over dx. So plugging dy over dt is 6 times tangent of t times secant square t, and we have dt over dx, which is 1 over exponential of tangent of t times secant square of t. So secant square will be cancelled out, and we will have dy over dx is equals to 6 times tangent of t over exponential of tangent of t. Now we have dy over dx, but this dy over dx is the variable of t, and we have the coordinate x and y. So we have x coordinate x1 and y1 is equals to the exponential and 3. So when we plug these values in this x and y to find the t, so we can say that x is equals to e and x is equals to the exponential of tangent of t equals to e. Comparing the power, we will have tangent of t is equals to 1 and t is equals to the tangent inverse of 1, which is equals to pi by 4. So we can say that slope of the tangent at point e comma 3 is equal to the derivative of y with respect to x at point t is equal to pi by 4, because the corresponding value for x is equal to 3 is t is equal to pi by 4. So we will have 6 times tangent of t means pi by 4 over e tangent of pi by 4. Solving further, we will have 6 times 1 over exponential of 1, and this one is equal to 6 over exponential. So we have the slope of the tangent, which is 6 over 3, and we have the point which is x comma y1 x1 y1, which is equals to the e comma 3. We will apply slope point form to find the equation of the tangent. So slope point form, y minus y1 is equals to mt times x minus x1. So plugging these values in this equation, we will have y minus y1 is 3 equals to mt, which is 6 over e times x minus exponential. So we have y minus 3 equals to 6 over e times x minus e. Solving further, we will have y minus 3 equals to 6 over e times x minus 6 over e times e. E will be cancelled out, and we will have y equal to 6 over e x minus 6 plus 3, and y is equal to 6 over e x minus 3. So this is the required equation of the tangent to the curve at point e comma 3. And this equation has the format y is equal to mx plus c. So here in this case, m is equal to 6 over e and c is equal to the negative 3.